Hello everyone, and welcome to our presentation. Today we're diving into the top 20 Java basics questions, perfect for both freshers and experienced professionals. This session is great for interviews and YouTube learning alike. We'll start with day 1, focusing on core Java interview questions. Over the next few slides, we'll cover key concepts that will help you prepare confidently. Let's get started. Let's take a closer look at what Java is. First, it's a high-level, object-oriented programming language. That means it's designed to be easy to read and write, while also supporting the concepts of objects and classes, which help organize code efficiently. Java is platform-independent, which is a huge advantage. Once you write your code, it can run on any device or operating system without needing to change it. This makes Java incredibly versatile and widely used across different environments. It's especially popular for developing enterprise applications, large, complex systems that businesses rely on every day. So, when we talk about Java, we're referring to a language that's powerful, flexible, and fundamental for many of the applications we use in the corporate world. Understanding Java's core features helps us see why it's such a cornerstone in software development today. Let's talk about how Java code works under the hood. When you write your Java program, it doesn't run directly on the hardware. Instead, it first compiles into something called bytecode. Now, this bytecode isn't specific to any one type of device or operating system. It's a universal intermediate form. This bytecode is then executed by the Java Virtual Machine, or JVM for short. The JVM acts like a translator that understands bytecode and runs it on the host machine. The great thing about this setup is that the same bytecode can run on any system that has a JVM installed, whether it's Windows, Mac, or Linux. And this is where the famous phrase, write once, run anywhere, comes into play. Because once you've written your Java program, it can be executed across different platforms without needing to change a line of code. So, why is Java platform independent? It all boils down to this ability of the bytecode to be interpreted by any JVM on any device. This independence is a core strength of Java, making it incredibly versatile and popular for cross-platform development. It ties directly into our broader theme of Java's flexibility and universal applicability in software development. Let's take a closer look at the Java Virtual Machine, or JVM. The JVM is a crucial part of Java's architecture because it executes bytecode, which is the intermediate code generated after you compile your Java program. This means that once your code is compiled into bytecode, the JVM takes over to run it, making Java platform independent. Another key role of the JVM is handling memory management and garbage collection. This is where the JVM automatically takes care of allocating and freeing up memory, so developers don't need to manage it manually. Garbage collection, in particular, helps clean up objects that are no longer in use, ensuring efficient memory use and preventing leaks. So, what is the JVM? Essentially, it's the engine that makes Java programs portable and efficient by executing bytecode and managing memory seamlessly. Understanding this helps us appreciate how Java runs smoothly across different systems without needing to recompile our code for each one. Let's take a closer look at the Java Development Kit, or JDK. This is the essential toolkit you'll use to develop Java applications. It includes everything you need to write, compile, and test your Java code, making it a comprehensive package for developers. The JDK contains the compiler, which translates your Java code into a form the computer can understand, and the Java Runtime environment, or JRE, which allows Java applications to run. Additionally, it offers various development tools that help streamline the coding process. Now, you might be wondering, what exactly is the JDK? Well, it's the complete environment for Java development. Think of it as the foundation that supports all your programming activities in Java. As we continue, you'll see how mastering the JDK is crucial for building robust and efficient Java applications. Let's take a closer look at the Java Runtime environment, or JRE. Essentially, the JRE provides the libraries and the Java Virtual Machine, or JVM, that are needed to run Java programs. Think of it as the environment where Java applications come to life and operate smoothly. When we ask, What is the JRE? It's the package that includes everything necessary to execute Java code without the need for the full development tools. This makes it ideal for users who just want to run Java applications. Connecting this to our overall theme, understanding the JRE helps us see how Java achieves platform independence, because as long as you have the JRE installed, your Java programs can run seamlessly across different operating systems. Let's take a moment to clarify the differences between the JDK, JRE, and JVM, as these are fundamental to understanding Java's architecture. The JDK, or Java Development Kit, is what developers use when they are creating Java applications. Think of it as the complete toolkit for development, including compilers, debuggers, and other tools. On the other hand, the JRE, or Java Runtime environment, is what you need to run Java applications. It's like a runtime package that contains everything necessary to execute Java programs, but doesn't include development tools. Now, the JVM, or Java Virtual Machine, is the core component that actually executes the bytecode generated by Java programs. It's platform independent, meaning it allows Java applications to run seamlessly across different operating systems. The key takeaway here is that the JVM runs the bytecode, the JRE provides the environment to run the JVM, and the JDK is used when you're developing and compiling Java code. Understanding these distinctions is crucial because they highlight how Java maintains its portability and flexibility across diverse systems. So after the code is written and compiled, what actually happens? Well, the intermediate code generated is stored in class files. These files contain the bytecode, which is a kind of machine language that the Java Virtual Machine, or JVM, can understand. Now, when you run your Java program, the JVM executes this bytecode. It's a key part of Java's platform independence, because no matter what operating system you're on, as long as you have the JVM, you can run this bytecode seamlessly. This process highlights how Java compiles code into a universal format, bytecode, that's then executed by the JVM, making Java programs portable across different systems. All right, let's talk about what a class really is. Think of a class as a blueprint or a template used to create objects in programming. It's like having a detailed plan that specifies what an object should contain. Now, within this blueprint, you'll find variables and methods. Variables are like the properties or data points that describe the object, while methods are the actions or functions that the object can perform. So essentially, a class defines both the state and the behavior of the objects you create from it. Understanding classes is fundamental because they help us organize code efficiently and create reusable, structured components in our programs. Let's talk about an instance of a class. Essentially, this is a specific realization of a concept or a template. It represents a real-world entity that we want to model within our system. When we say instance, we're referring to a concrete object that has its own unique data and characteristics. Now, why is this important? Because understanding instances helps us see how abstract ideas become tangible within our applications. For example, if we have a class called car, an instance would be a specific car, like a red Honda Civic with a particular license plate. This ties into the broader theme of object-oriented programming, where we model real-world things as objects, making our code more intuitive and closer to how we think about the world. When we create instances of classes, we're essentially creating these real-world entities within our software. So, in summary, an instance of a class is a specific, concrete example of a concept that allows us to represent real-world entities within our programs. This approach makes our code more flexible, reusable, and aligned with real-world scenarios. Now, let's talk about a special method we use to initialize objects in programming. This method shares the same name as the class itself, which makes it easy to identify. One key thing to remember is that this method does not have a return type, not even void. So, when you see a method with the same name as the class and no return type, you're probably looking at a constructor. So, what exactly is a constructor? Well, it's a special kind of method designed specifically to set up new objects. It gets called automatically when you create a new instance of a class, helping to initialize the object's state right from the start. This concept ties into our overall theme of efficient object management in programming. Proper use of constructors makes our code cleaner and more reliable because each object is initialized consistently. Remember, understanding constructors is fundamental to mastering object-oriented programming. Alright, now let's look at slide 12, which shows the entry point of a Java program. Here, we see the method public static void main, string args. This is what Java looks for when starting a program. Think of it as the main door through which everything begins. The main method is always the starting point, regardless of what your program does afterward. When you run your Java application, the runtime environment calls this method first. The public keyword means it's accessible from outside the class, which is necessary because the Java runtime needs to access it. Static indicates that this method belongs to the class itself, not to any particular object. And void simply means this method doesn't return any value. The string args part allows you to pass command line arguments to your program, which can influence how it runs. Overall, understanding the main method is fundamental because it's the entry point that ties everything together, guiding your program from start to finish. Let's take a closer look at Java tokens and identifiers. On this slide, we're focusing on a few key concepts. First, tokens are the smallest units of meaning in Java code, including keywords, identifiers, literals, and operators. Each of these plays a crucial role in how the language functions and how our programs are structured. Next, identifiers are essentially the names we give to variables, classes, and methods. These names are what we use to reference different parts of our code, making it readable and organized. It's important to choose meaningful identifiers so that our code remains clear and maintainable. Remember, understanding how tokens and identifiers work is fundamental because they are the building blocks of any Java program. Recognizing these components helps us write better code and debug more efficiently. This knowledge ties back into the overall theme of mastering Java syntax and writing clean, effective code. Let's walk through how a Java program actually executes, step by step. First, you write your code, the source code that you want the computer to run. Then this code is compiled, which means it's translated into an intermediate form called bytecode. This bytecode is not machine-specific. Instead, it's designed to be portable. Next, the bytecode is sent to the Java Virtual Machine, or JVM. The JVM acts as a bridge, interpreting or just-in-time, compiling the bytecode into machine language that your specific hardware can understand. Finally, the JVM executes this machine code, allowing your program to run smoothly on any device that has a compatible JVM. This process highlights Java's core strength, its portability, by separating the compilation from execution. All right, let's wrap up our session with a quick overview of the core Java interview questions we covered today. We started with the basics of Java, making sure everyone understands the fundamental concepts. Then, we moved on to the JVM, JDK, and JRE. These are essential for understanding how Java operates behind the scenes. We discussed what classes, objects, and constructors are, highlighting how they form the building blocks of Java programming. We also looked at the program execution flow to see how Java programs run step by step. Finally, we summarized everything from day one, emphasizing the importance of these core concepts as a foundation for more advanced topics. Remember, mastering these basics is key to succeeding in interviews and becoming proficient in Java.